Okay, the last part of the section is the converse of the Pythagorean theorem. And what this allows you to do is to determine whether a triangle is not only right, but if it is obtuse or if it's acute. So stating the obvious here, first of all, if you have a right triangle, what's going to happen is if a squared plus b squared does equal c squared, if that's a true statement when I set up my numbers, then it's a right triangle. Can't work any other way. Okay, so a squared plus b squared doesn't always work. First of all, I like to think of this, I want to really focus in on this right angle and what would happen to it if I made this one, this side here, the hypotenuse, longer than it should be. Okay, so I've got my right triangle here, but if I was to extend that third side, okay, if this gets longer, it's going to take these and spread these apart more. So this is no longer a right angle. This would make an obtuse triangle. Okay, so again, if this was A and this is B, and C got too big, in other words, if A squared plus B squared, if these are smaller than the potential hypotenuse, then it has to be an obtuse triangle. Again, think of it in terms of the potential hypotenuse. If it is a right triangle, everything is good. A squared plus b squared would equal c squared. But if I extend c squared too much, or this side too much, it creates an obtuse angle, therefore an obtuse triangle. Okay, so the other possible case, again, if a squared plus b squared does equal c squared, it fits just right. But what would happen if I took this c side and I shrunk it down? Okay, again, I want to think about what's going to happen to this right angle. It was standing straight up, but I had to shrink it because c got smaller. Okay, so if a was here and b was here, this angle right here is acute. In fact, these two would also be acute, so it would be an acute triangle. So if you apply the Pythagorean, the converse of the Pythagorean theorem, and a squared plus b squared is bigger than c squared, and again, I like to think of this as, hey, this is too small, this is shrinking it down. Smaller and smaller it gets. It was 90, now it's down to almost nothing. It's going to be an acute triangle. Okay, so now for the converse of the Pythagorean theorem, you really just have three cases. Okay? Either this c side, again, is too short. If it's too short, then it is acute. It makes the 90-degree angle too small. This side, what happens if this third side, the potential hypotenuse, or the c side, is too big? It's going to make your 90-degree angle open. This is too big. If your c side is too big, it's an obtuse triangle. But in this case, if a squared plus b squared is equal to c squared, it's just right. And a little bit of a play on words there, but just right. I think it's probably better to think about this and visualize this in these three cases rather than try to memorize the greater than or less than symbol in that theorem. Makes things a lot easier to remember. Okay, the last problem in this section will be the last got it problem on page 495. Got it. Number 5 is a triangle with side lengths 7, 8, and 9. Is it acute, obtuse, or right? Again, so I'm going to look at these three. Again, I have to think of that as an 8, a B. This is the longest side, so it's the potential hypotenuse. Okay, so I'm not sure if it's too big, too small, or just right. So let's apply the Pythagorean theorem. 7 squared plus 8 squared is equal to 9 squared. Again, I'll put a question mark because I'm not really sure. Okay, so 7 squared is 49. 8 squared is 64. 9 squared is 81. Okay, I can already tell what's going to happen here. 49 plus 64 is going to be 113. 113 is not equal to 81. In fact, 81, which is supposed to be the hypotenuse, is much smaller than this. So, it's too small. Again, what happens if your potential hypotenuse is too small? Just draw a picture and let's find out. So if it's too small, that's going to shrink down my right angle. This is much smaller than the 2 legs squared combined, so that angle has to be much less than a 90-degree angle. So it is an acute triangle. Okay, this next problem is number 30. I thought we should do one more of these. Number 30 on page 496. And it's asking if it's an obtuse, acute, or a right triangle. So the sides they give me, square root of 3, which is a little bit different, 2, and 3. Okay, don't be afraid of this number right here. It's just a number. Okay, it's around 1.73. You punch it into your calculator, and I can deal with these. So watch what happens here. Again, I don't know if this is a right triangle or not, but these two sides would have to be the legs. 3 is the longest of these 3 that are listed, so it has to be the potential hypotenuse. Okay, so I'm going to ask here, square root of 3 squared, 2 squared, does it equal 3 squared? Okay, so let's work this out. This right here, don't be afraid of this. If you square this, it's just the square root of 3 times the square root of 3. This 2 undoes the square root, and that works out pretty well. 2 squared is 4. 3 squared is 9. Okay, again, 3 plus 4, that doesn't equal 9. It's too small. Okay, or if I look at it in terms of the 9 is too big. Remember that this is the potential hypotenuse. Well, what happens if the hypotenuse is too big? So if I draw a picture of that, I draw a triangle. Might be exaggerating this a little bit. But the C side was too big to be a hypotenuse. Now again, if it's too big to be a hypotenuse, that's going to take this side, it's going to extend it, going to take your 90-degree angle and open it up too much to where it is an obtuse triangle.
Well, it's another great day to be a Titan.